Identify the constant variable. The problem states that all four containers are maintained at a constant temperature of 273 Kelvin. Understand the relationship between temperature and kinetic energy. According to the kinetic molecular theory, the average kinetic energy, Ke average, of gas particles depends solely on the absolute temperature, T. Because all containers are at the same temperature of 273 Kelvin, the average kinetic energy of the gas particles in containers 1, 2, and 4 is identical. Analyze the relationship between speed, mass, and kinetic energy. The formula for kinetic energy is Ke average equals 1 over 2 mv to the power 2, where m is the mass of a gas particle and v is its speed. This can also be represented as root mean square speed. VRMS equals square root of 3RT over m, where m is the molar mass. At a constant temperature, average speed is inversely proportional to the square root of the molar mass of the gas particles. V is proportional to square root of 1 over m. Therefore, the lighter the gas particles, the faster they must move on average to have the same average kinetic energy. Determine the molar mass of each gas. Find the molar masses for the gases in containers 1, 2, and 4. Container 1, helium, He, has a molar mass of approximately 4.00 grams per mole. Container 2, neon, Ne, has a molar mass of approximately 20.18 grams per mole. Container 4, sulfur dioxide, SO2, has a molar mass of approximately 64.1 grams per mole. Compare speeds and select the correct option. Since helium, He, has the lowest molar mass, 4.00 grams per mole, its particles must have the greatest average speed to maintain the same average kinetic energy as the heavier neon and sulfur dioxide molecules. This confirms that the average speed is greatest in container 1, making option A the correct answer. The correct answer is option A, greatest in container 1.